Hi everybody, welcome back. So today in this video we want to talk about inverse functions. So up to this point we've talked about function notation and what a function is and how we can relate them to graphs and how we can compose them. And this video is going to be all about how can we undo a function. Alright, so what we're going to do is we're going to start out with a function f of x equals 4 times x plus 3. So what this function is doing is it's taking some input. So from our notation, we know that our input here is x. This is our input. And the first thing that's going to happen to my input is I'm going to multiply by 4. And then the second thing that's going to happen is I'm going to add 3. So what I'm going to do is make an analogy here about putting on your socks and then putting on your shoes. So the order in which I did these things, and the typical order that we put on our socks and shoes, is we put on our socks first. So I'm going to call multiplying by 4, putting on my socks, and then I'm going to call adding 3, putting on my shoes. So we have some input, which would be our foot. We put on our socks first, and then we put on our shoes. Now, if I want to undo this process, the first thing that I have to do is I have to take off my shoes. And then, and only then, can I take off my socks. So if your shoes are still on and then you try to take off your socks, you're going to be in a little bit of trouble. So let's go ahead and let's create a new function that's called g of x. And let's see if we can think about this process of taking off my shoes and then taking off my socks. So the first thing we do is we have an input. We have sort of our foot here. And what I'm going to do is I'm going to remove my shoes. So if adding 3 was putting on our shoes, then subtracting 3 is going to be removing my shoes. So the first thing I'm going to do is I'm going to take off my shoes, and then after that, what I want to do is, well, take off my socks. Now, putting on my socks was multiplying by 4, and so taking off my socks is going to be dividing by 4. So this new function over here, g of x, that I've created is called the inverse function to f of x. And what it does is it undoes anything that f of x did to your input. So multiplying by 4 and adding 3, in order to undo that, I would subtract 3 and then divide by 4. So let's see what this means formally. How do we check, or how do we verify that two functions are inverses? So what I'm going to do is create a new function using function composition. So I want to create the function f of g of x. Now what's going to happen is g of x is going to do something to my input, and then f of x should undo whatever happened. So the end result to x should be that there is no change. Nothing happened in the end. Whatever my input is to start should be what it is when I'm all finished. And so in order to verify that, what we have to do is we have to look at our formulas for function composition. So the first thing we're going to do is we're going to look at g of x. And I'm going to replace this g of x here. So I'm going to replace this g of x with the formula. So the formula that I have for g of x is given above. So we have f of whatever g of x is. And it turns out that that's x minus 3 over 4. Okay, so we have that above. Step 2, we're going to take our function f and look at what it's doing. So whatever our input is, you multiply it by 4, and then you add 3. So it turns out that our input here is x minus 3 over 4. Now, let's just think about this before we go ahead and do all the algebra, what's happening. So right here I have a 4 on the outside. So this is multiplying by 4. And then down here I have a dividing by 4. So if I'm multiplying by 4 and then dividing by 4, what we would say is these two things are going to cancel each other out. And then once those are gone, we see that I have this, I'm subtracting 3, but I'm also adding 3. So we would expect those to also cancel each other out. So let's go ahead and take one step and let's cancel these 4's here. And we'll say what I'm left over with is this x minus 3, which was from the inside, and the plus 3, which was on the outside. Now, subtracting 3 and adding 3, those undo each other, and so those go away. And what I'm left with is just an x. So this process of composing f and g shows me that whatever happens to x, whatever I plug in as my input right here, whatever it is, it's going to go through all of this process. So all of this stuff is going to happen, but everything cancels out, and so x remains unchanged in the end. So f and g, they undo whatever the other function did. Okay, and so this process tells us that f and g are inverse functions. And so formally, what we have is we say two functions f and g are inverses if the following two things hold. So we want f of g of x to equal x, and if we do the composition in the other direction, we want g of f of x to be equal to x. Okay, so what we had above was one example of an inverse function, and one of the themes for our course, what we'll see over and over again, is as we introduce new functions, it's going to be very common for us to ask, well, what's the inverse? In a lot of the cases, we're going to be thinking about functions in pairs. A function and its inverse go quite well together. So stay tuned for the next video, and we'll talk about how we can look at inverse functions graphically. See you then.